Okay, this video is to explain some of the big ideas in physics at level 1. So here's an overview of our big ideas on the triangle, and the main big ideas that we talk about in physics are energy, forces, and looking at relationships between different quantities. And we're going to be looking at motion as a way of investigating those big ideas within physics. So I'm going to give you some examples of how all of this links together in this concept map. So we'll start off looking at motion. So we start off with motion because it's really nice to start off with what you can actually see to give us a feel for some of the big ideas. So as an example, you might be looking at an object that's moving along, and you look at the distance that that object is covering, and also think about the amount of time that it takes to cover that distance, and that leads us to the idea of velocity or speed. So how fast is something moving? And so if we were looking at transport like we will do, we could look at cars and how fast a car is moving. We also, when we think about speed, we also then go on to think about acceleration. So how quickly does that velocity change? So when we're looking at these, it's really useful to not only be able to describe it in words and use that vocab, but also to look at different ways of representing the relationships between those different ideas. So what we do is with all of these, we'd go on to look at graphing what's happening. So the first type of graph we would look at is a distance time graph. So usually time across the x-axis, distance up the y-axis, and like graph the motion of a car as it's moving along. And we might, instead of looking at distance and time, sometimes we investigate velocity and time and how that changes. So a car might be over time speeding up as it's moving away from some traffic lights. Graphs are really nice because they allow us to describe what's happening in a situation without having to use a lot of words. So we can look at a graph and get a lot of information quite quickly. Graphs as well, if we investigate the graphs a bit more, if we do rise over run, which is a gradient, you'd be probably used to that in maths. For a distance time graph, that'll tell us the velocity. And then if we did the same with rise over run and get the gradient for our velocity time graph, that'll tell us about the acceleration. And that's really handy. And another handy way to describe that would be using some maths. So looking at v for velocity, which is equal to distance divided by time. So we can actually start doing some calculation and come up with some numbers. So if we know how far your car has moved and how long that took, we can figure out its velocity. The same idea is true here for velocity and time graph. We can actually get our acceleration, which is equal to the velocity divided by the time. So again, if we know how quickly a velocity has changed and how long it took, that'll give us our acceleration. Okay. So once we've had a good look at motion, we then think about, well, we can see that motion, what was actually causing it, and we have a look at forces. Forces, they can be described as pushes or pulls. We use arrows very often to show the direction of the push or the pull, and we also name them. So it might be a friction force or a weight force. We do get very picky in weight and mass, so we'll talk more about what's the difference between weight and mass and how do we use it in physics compared to how do we use it in everyday language. We, with forces, could look at the idea of balanced and unbalanced forces. And you'll learn more about exactly what that means. That's a way of looking at how do all the forces on an object add up. And if we've got balanced forces, that tells us that, if we think about what does that mean for motion, that the object is either stationary, so it's not moving at all, or the object could be moving with constant velocity. So that means its speed isn't changing, it's not speeding up, it's not slowing down. So that's the two options if we've got a balanced forces acting on an object. Unbalanced forces though, that means when there's force in one particular direction is bigger than all the other forces. That means the object is accelerating. So that would mean if your car's pulling away from the traffic lights and speeding up, there must be an unbalanced force acting on it to make it speed up and move away. This idea of balanced and unbalanced forces and what it means for motion is really nicely described by a couple of Newton's laws. So you'll be learning about Newton's laws of motion. And again, linking to our relationships, if we think about Newton's second law of motion, very often that's summarised by saying F equals ma, which means the force is equal to the mass times the acceleration. So as an example, if you've got a very large mass, you need a big force to make it accelerate. If you've got a small mass, you don't need as much force to make it accelerate the same amount. Okay. We'll then go on to look at energy, because energy is also linked in with forces and is linked in with motion as well. So energy, if we were to try and describe what energy is, sort of a definition that you'll often see is the ability to do work. And again, we use work in a different way in science than we may do in everyday language. So when we use the term work, what we mean is energy that is transferred. So work itself is a measure of energy. So energy that is transferred. So, or we can talk about transformed. That's another word you might hear. So transferred means that energy is going from object to object. That could be thinking about cars in a collision. One car collides with another car, and some of the energy from this car is transferred to the other car and makes it move. Or we could be looking at transformed. So that could be, for an example, a parachutist, when they jump out of the plane, when they're up high, they have a certain type of energy, gravitational potential energy, and that then is transformed into a different type of energy, kinetic energy, as they move downwards. Another example that's quite useful to think about is a person moving an object. So if you had a person pushing on a box and moving it along, they would be using chemical potential energy. So in their muscles from the food that they've eaten, and as they move it, the box, they change it, that chemical potential energy that's in their muscles into the kinetic energy of the box that's moving along. And again, like we looked at with forces, velocity and acceleration, we can actually do some calculation and put some numbers with that, like give it a value to show us the size. So with gravitational potential energy, the relationship we look at, EP for gravitational potential is equal to mass times g, which is our value for acceleration due to gravity, times h, which is the height of the object. Our value of g, our acceleration due to gravity, which means how quickly do objects that are falling accelerate, is always the same. So you'll be learning about that as you link together ideas about acceleration and energy. And then in kinetic energy, the relationship there, EK for kinetic energy, a half times mass times velocity squared. So the amount of kinetic energy that an object has depends on its mass. So if it's a bigger mass, it will have more kinetic energy, and its velocity, so the faster it moves, it has more kinetic energy. So coming back to this idea here, how do we link then with forces? Well, the person moving the box along is a good example to link through to that. We come back over to here and we look at another definition of work, which links nicely to that example. Work can also be defined as when a force moves an object through a distance. So when a force moves an object, like the box in this example, and it's moving along over a distance. So moves over a distance. So obviously, if I said a force is moving it along, and we learnt back here with forces that forces make things move. that links idea of an unbalanced force must be there to make an object move and transfer that energy. And again, we can also link into, hey, how could we do some calculation there? Well, work is equal to the force times the distance. So that's a very quick summary of all of the big ideas and how they link together. At the moment, if you're looking at this before you start the unit, there may be questions that you've got there. There may be areas that you recognise from what you've done in Year 10 Science. As you go through the learning in the unit, you'll be learning about each of these areas, and then if you come and watch this video again at the end, you'll be able to look back and see all of the links and all of the areas that you filled in your learning.